Chapter 10, Section 2, Simplifying Radicals, Part 1. A radical expression is going to contain a radical or a square root. A radicand is going to be what is inside the radical. So if I was taking the square root of 4, my radicand would be 4 because that is what I'm taking the square root of, and that's what's inside of my radical symbol. A radical expression is simplified if all of the following are true. The first thing that we need to check is that the radicand has no perfect square factors other than 1. The next one would be that the radicand contains no fractions. So what's inside of my square root cannot be a fraction. And the final thing that we need to make sure we do not have is no radicals appear in the denominator of a fraction. The main thing that we're going to talk about today is just the first one, that the radicand has no perfect square factors other than 1. We're going to get into the division and the fractions a little bit later in the next lesson, so today we're going to mainly focus on that first one, that it has no perfect square factors other than 1. The multiplication property of square roots says that for a is greater than or equal to 0 and b is greater than or equal to 0, the square root of a times b is going to be equal to the square root of a times the square root of b. So I can basically break up my factors a and b and take the square root of each factor separately, but multiplying those together. An example of this says, what is the simplified form of the square root of 125? Well, 125 is not a perfect square. No whole number times itself is going to equal 125. So what I'm going to have to do is I am going to have to to simplify this radical, I'm going to find the largest perfect square factor of the radicand. In this case, my radicand is 125. The largest perfect square that will go into, or that is a factor of 125, is 25. So 25 is a perfect square, so what I'm going to do is I'm going to rewrite the square root of 125 as the square root of 25 times 5. Notice if I multiply 25 times 5, I'm going to be back to having 125 in my radical. What I'm going to do now is use the multiplication property, and I'm going to break up this radical into two radicals being multiplied together. So instead of the square root of 25 times 5, I'm going to have the square root of 25 times the square root of 5. Notice this is really nice because the square root of 25 is a perfect square, which means it's going to be a whole number, and the square root of 25 is 5. So I can go ahead and simplify the square root of 25, but the square root of 5 is not a perfect square, so I'm just going to have to leave it alone, leave the square root of 5 alone, which gives me my answer of 5 square roots of 5. I get the 5 on the exterior of the radical because the square root of 25 was 5, and I need to multiply that by the square root of 5 because that was what was on the interior of my radical, and it is not a perfect square. It's going to be irrational if I take the square root of 5. So that would be my simplified radical. The square root of 125 is equal to 5 square roots of 5. One thing that you always need to double check and make sure of is that your radicand that you're ending with, in this case it's the 5 that's on the inside of my square root symbol, is that it has no perfect square factors. So the only two numbers that I can multiply together to get 5 is 1 times 5, or two whole numbers that I can multiply together. 1 is a perfect square, but it's going to be an exception. It's the only perfect square that I can have on the inside as a factor. And then 5 is not a perfect square. So this has been simplified as far as I can go. This next example says, what is the square root of 108 simplified? And I'm going to do this one a little bit differently. What I'm going to do is I'm going to show you how to do this problem if you do not find the largest perfect square at first. It's really easy if you make a list of your perfect squares. So your perfect squares would be 1 squared is 1, 2 squared is 4 would be a perfect square, 3 squared is 9 would be a perfect square, and you can make a list of those, and that would be nice to have if you wanted to do that. And what you can do to figure out if it's a factor is you can just take 108 or your radicand and divide it by each of those. If you get a whole number, then it is a factor. If you get a decimal, then keep trying different problems. I know that 36 will go into 108 evenly, and that's going to be my largest perfect square factor. But if I did not realize that at first, this is the method that you're going to use. It is always going to be easier if you find the largest perfect square first. I just want to put that out there. But sometimes you don't want to start the problem completely over if you've already done a couple of steps. So I'm going to show you what to do if you don't find the largest perfect square first. Let's say that I notice 4 is a factor first. 4 is a perfect square, and 4 is a factor of 108. So what I can do is I can rewrite the square root of 108 is equal to the square root of 4 times the square root of 27, or times 27. I'm going to use the multiplication property to break this up and say the square root of 4 times the square root of 27. I can take the square root of 4, the square root of 4 is 2, and then I need to multiply that by the square root of 27. So my first step, I would get 2 square roots of 27. And that looks really nice and fine until you check 27. 4 doesn't go into 27, but 3 squared 9 does go into 27. So when you look at your radicand and to see if it has any perfect square factors, 27 does. 9 is a factor of 27. So I'm going to use the same method and do it all over again, but this time I need to be careful and keep my 2, the constant, out in front of the square root of 27. I need to keep that with this, so be careful when you're rewriting it. Now I'm going to take 2 square roots of 27, and I'm going to set it equal to 2 square roots of 9 times 3. Go ahead and use your multiplication property and break this up into 2 square roots of 9 times the square root of 3. This is what you need to pay really close attention to here. I'm multiplying 2 times the square root of 9. We know that the square root of 9 is 3. But because we have a constant being multiplied by the square root of 9, we're going to have to multiply the constant that is there 2 times the square root of 9, which is 3. So 2 times the square root of 9, or 2 times 3, is 6, and I'm going to be left with the square root of 3 still inside my radical. So this simplified final answer is 6 square roots of 3. 3 does not have any perfect square factors besides 1. If you go back to this problem, and I could have written originally, I could have said the square root of 108 is equal to 36 times 3. Break it up into the square root of 36 times the square root of 3. Well, the square root of 36 is 6, so I'd be left with 6 square roots of 3. It's going to be a much faster and way to solve this problem, and it's also going to be less steps or less parts for you to make mistakes on. So if you can always find the largest perfect square that goes in is a factor of your radicand, that's going to be amazing and it's going to help you a lot. But if you don't find the largest perfect square factor, it's not the end of the world. You don't have to restart the problem completely. Just remember to multiply your perfect square, the square root of your perfect square, times the number that's already there. Simplifying radical expressions with variables. A variable with an even exponent is a perfect square. A variable with an odd exponent is the product of a perfect square and the variable. Examples of this, I could take the square root of 8, the square root of x to the 8th. I can rewrite x to the 8th as x to the 4th times x to the 4th. Well, remember, any number times itself. If you're taking the square root of a number times itself, it's just going to be that number. So my answer would be x to the 4th. Something that I really quickly want to tell you is that if you are taking the square root of a variable to a positive exponent, your answer is always going to be half of the even power. So here I was taking the square root of x to the 8th. The square root of x to the 8th is going to be x to the 4th, which 4 is half of 8. Now an example with an odd exponent, if I was asked to find the square root of x to the 7th, I can rewrite this as the square root of x to the 6th times x. Remember, when you're multiplying powers with the same base, you add the exponent, so it's going to be equivalent to x to the 7th, x to the 6th times x. I can take the square root of x to the 6th. The square root of x to the 6th is going to be x cubed, and I'm going to be left with the square root of x on the inside of my radical, or my radicand would be x. This next example says, what is the simplified form of the square root of 243x to the 5th? The first thing that I need to do is I have a product on the inside, or a product is a radicand. So I need to find the largest perfect square factor of 243, and then I'm also going to need to break up x to the 5th because it's an odd exponent. I'm going to rewrite x to the 5th as x to the 4th times x, because x to the 4th would be a perfect square, and then times x would give me the x to the 5th. The largest perfect square factor for 243 is going to be 81. So I can rewrite this as the square root of 243x to the 5th. I can write as 81x to the 4th times 3x. 81 times 3 gives you 243, and then x to the 4th times x gives you x to the 5th. Go ahead and break this up using the multiplication property, and you get the square root of 81x to the 4th times the square root of 3x. Well, the square root of 81 is 9, and the square root of x to the 4th is x squared. So the square root of 81x to the 4th becomes 9x squared, and then times 3x. So my answer here is going to be B. The multiplication property of square roots, again, this time we're going to work in the opposite direction, says that for a is greater than or equal to 0 and b is greater than or equal to 0, if you have the square root of a times the square root of b, that's going to be equal to the square root of a times b. So this time I'm just kind of working in the opposite direction as I was previously. This example asks us, what is the simplified form of 3 square roots of 12z squared times 5 square root of 4z? You have an option here. Both the square root of 12z squared and the square root of 4z can be simplified right now, and you could choose to go ahead and do that. I didn't. It's not really going to matter in the long run if you simplify now or if you simplify later. Whichever one you prefer is totally fine. 4 is a perfect square that could go into 12, and then obviously z squared is a perfect square, and then 4 is a perfect square, and you could bring out a 2 and you would multiply that by 5. So whichever one you want to do is totally fine. I didn't for this problem, just to show you kind of the method that you use, because this is going to be an easier way to show you if I just don't simplify at the moment. Notice both of these radicals have numbers or constants on the outside, so I need to multiply the numbers on the exterior of the radical, and then I also need to use the multiplication property of square roots to multiply my two radicands together. So 3 times 5 would give me 15 square roots of my the product of my two radicands. So the square root of 12z squared times 4z. Go ahead and multiply 12z squared times 4z, gives you 48z to the 3rd. What I'm going to do now is find the largest perfect square factor of 48, and then I need to break up z cubed as z squared times z, and when I do that, I'm going to get 15, and 16 would be my largest perfect square factor, so 15 square roots of 16z squared times 3z. Notice 16 times 3 is 48, and z squared times z is z to the 3rd. You can go ahead and break this up as the square root of 16z squared times the square root of 3z. And when you do that, you can take the square root of 16z squared. The square root of 16 is 4. Remember, when you bring out the 4, you're going to need to multiply that by 15. So 15 times the square root of 16, which is 4. And then z squared, the square root of z squared is going to be z. You cannot simplify 3z any more than it is already. So I'm going to have 15 times 4z, which is the square root of 16z squared, and then times the square root of 3z. Well, 15 times 4z gives you 60z. So your final answer is 60z square roots of 3z. This last example says a boat traveled 4 times as far due east as it did due south. What is an expression for the distance the boat would have traveled in a straight line from its starting point to its destination? An easy way to use when they use directions, you need to clarify which is north, south, east, and west. I like to just generally speaking say that the top of my page, or in this case the top of this slide, is going to be north. You might have heard never eat sour watermelon, never eat sour worms, any of that good stuff to remember your north, south, east, and west. So I have a boat, and I'm going to go east, and then I am also going to turn and go south. It tells me a boat traveled 4 times as far due east as it did due south. So I don't know how far south it went, so I'm going to assign it the variable x. But I know that it went 4 times x further east. So I'm going to say that this side would be 4x. And then it says, what is an expression for the distance of the boat would have traveled in a straight line from its starting point, so in this case from the boat, to the larger red dot on the bottom right side. So it's asking me the straight distance from the boat to that point, and I'm going to just say that that's going to be my question mark. If you notice, what's been created here is a right triangle, which we talked about in the last lesson. I know 2 sides of my right triangle are 4x and x, and they're wanting me to find an expression for the distance from the boat to that point, or in this case, I just put a question mark, or the black dotted line. If I know 2 sides of a right triangle and I want to know the third side of the right triangle, I can use the Pythagorean theorem. Remember, a squared plus b squared equals c squared. A and b are your legs that form the right angle. In this case, my 2 legs would be 4x and x, and my hypotenuse is I'm just going to plug it in as a question mark. You can assign it y or z or whatever, or h maybe for hypotenuse, whatever you want to do. Notice, very important here, I plugged in 4x. I plugged it in parentheses, which means I need to square both the 4 and the x. So 4x in parentheses squared becomes 16x squared plus x squared equals that side length squared. Well, 16x squared plus x squared, I can combine those or add those because they are like terms. They have the same variable x to the same degree squared. So 16x squared plus 1x squared will give me 17x squared. If you remember from the last lesson, is that the inverse of squaring something is to take the square root. So I need to take the square root of both sides. So I have the square root of 17x squared is going to be my answer, except for I can simplify that. Now 17 is a prime number. It does not have any factors besides 1 in itself, and it's not a perfect square for sure. But x squared is a perfect square. So what I'm going to be able to do is I'm going to be able to take x squared and bring the square root of x squared, out in front of my radical, which gives me an answer of x square roots of 17. Today's assignment is on page 634. It's numbers 2 through 32 even.